Hi guys, this is .NET GAN India YouTube channel, and in this video I am going to create an application using Python and LlamaIndex and Gemini as a LLM model. And in this application we will be query a local document. We will embed the local document and ask the question uh, about local document content. So I am using Visual Studio Code as a code editor in this application creation. So let's start the implementation. First you need to go to terminal and create a new terminal, and we need to install some libraries, Python libraries: LlamaIndex, LLMS Gemini, LlamaIndex embedding Gemini. So these three libraries we will be going to use to create the application. So first we will install using pip command, and we will install these three libraries in our on our local machine. The packages are installed. So let's create one file in this folder, demo.py, you can name it. Now we need to import OS library, then OS dot environment, and in that we need to pass environment key and use the Google API key inside it and assign the API key. So I have already copied the API key from Google AI Studio. You can also generate the key from Google AI Studio from aistudio.google.com, this website, and from that you can go to the create get API key, and then you can generate your API key easily. You can use your Google account to log into this AI Studio application. So from here you can generate. So I will leave it now because I already have a key, so we'll use that only. Okay, so let's move on for the next step. Now what we will do is we will import one more library from llama underscore index dot embeddings, and then Gemini, and from that we will import the Gemini embedding library, and then we will use this Gemini embedding object now. So we are creating one variable where we will assign the Gemini embedding object. Inside this Gemini embedding we need to pass the embedding model name. So I already copied that in notepad, so I am going to use the models slash embedding hyphen 001 model. So now the variable is initialized. So now we will need to use we need to create a Gemini object. For that we need to get import the Gemini package from LlamaIndex LLMS Gemini and from that we will just create a Gemini object and assign to the LLM object. So we did also. Now we will uh, tell the Llama index that what LLM we are going to use. For that we need to use the settings object of Llama index. For that we need to import the settings uh, package from LlamaIndex.core. So we are importing now settings. So if you don't do a settings, use the settings object, then it will have a default setting of OpenAI. It will use OpenAI as a embedding and LLM model. So if you specify the LLM, then only it will use that LLM model for your application. So this is the okay, there is a problem when we need to use import there. Okay, so for uh, for this application we are using Gemini, so we are telling Llama index that use Gemini LLM as a LLM model. So we are set up that model settings. So we have already assigned LLM object to the LLM dot settings dot LLM. Now embed model we have assigned settings dot embed model. Then now we will use the node parser. So node parser is that we need to whenever the embedding happens, then we need to split a sentence so that the token will there is a limitation of tokens, so we will use the sentence splitter for that. For that we will use one package, a LlamaIndex.core.node parser, and from that we will import the sentence splitter package. So we are importing sentence splitter package. Inside that we will set up the chunk size and chunk overlap. In this we will set 512 as a chunk size, and the chunks overlap would be, you can set 20. In your case you can increase it also. So now the next setting is we will going to do is how much output, how much output should be written by the LLM. For that num output we are setting a 2000 as a output number, and the context window. So whenever context is sent to the LLM, that length we are also defining. So now the settings are done. Now we are doing a embedding setting. So we are using for embedding we need to import one document, local document. For that we are just using the simple directory reader. Inside that we just need to pass the folder path. So in our case we are using doc, and then you just need to call the load data method. And we are since we have defined doc folder, so we are creating we need to create that doc folder. So we have created doc folder. We will now going to save. I already have this CCC language specification document. This is a PDF document. We are saving in that path. So just copy this path and save the PDF to. We will going to save this PDF to that path. Click on save, then yes, the document is saved. Just let's check that the document is come or not. Yes, it is showing in the doc path. So whenever this application loads, then it will load all the data, all the files of that doc folder, and it assigned to the documents object. Okay, so for whenever this application run, so all the documents will be iterate, and we will embed all the document, and we will use the vector store index. So it will store the embeddings in memory, since we have not specified the embedding db yet. So by default it stores in the memory. So vector store index, we will pass the documents object which is we have created, and now the index object will be initialized using vector store index from documents. So now what we will do is we will use the query engine object to query the documents, or query whatever we want to ask the question. For that we need to use the index dot as query engine method to initialize the query engine object. Okay, so our embedding part is done, our settings are done. Now what we will do is we will create one small batch file or batch code, where the user will input the questions. For that we will use a while loop. So wherever str input is exit, it will exit the application, else it will wait for the user input. So this is the simple batch program we will write. So for that str input we will check whether it is blank or not. If it is not blank, then only we will query to the LLM. So this is the program, and then we will use the query engine object dot query, and we will pass the user input to query method, and it will return a response, and we will going to print that response. So we are using /n so that we will have a new line, so that it can be readable easily in else. And then we will take a input str and assign it to str input. Since it is while loop, so it will wait for the user input unless it will user will write down the exit. So we have input, and we will ask the question from the user, get the question from the user, and print the output. So I think our program is done. Let's save it and just run this program. For that you need to write the command python space demo.py, because our application name is demo.py. So run it. So whenever you run it first time, it will take time to start the application, because it is embedding your local document. Depending upon the size of your document, it will take time. So in my case it is not that lengthy document, but it will take time to embed, because we are chunking the document text, and then we are storing in memory. So it will take time. Yes, the embedding is done, and now application can be usable. So let's ask the question, what is the document about? Okay, then let's see what the answer will be. Yes, the answer is CAM. The document is about CCC language specification. So this is the document which is related to CCC language specification. So it given a correct answer. Let's ask another question. What is the simple types in CCC? Let's see. Simple types include numbers, boolean. Okay, let's take this in a detail. I will ask that explain in detail. Okay, so now let's see what will be the answer. Okay, so LLM given a detailed answer. Okay, so far so good. Let's ask another question. What are keywords available in CCC? So it should return a keyword list. Okay, so I got all the keyword list as per the document. So these keywords are mentioned in the document. Let's exit it. So far so good, because we have used in memory. So let's try to store it. If the documents are heavy, so it is practically good to store in a persistent or in a disk. The embedding should be stored in a disk. Currently in this application, it is storing in a memory. So let's convert this into persistent storage. So what we will do, we will use the uh, use the llama index persistence. So what llama index can do is, llama index can store the embeddings in a JSON file in a specified folder. So we have defined one folder, persist directory. In the storage folder, it will, if the storage folder is not there, then it will create a storage field folder, and then it will store all the embeddings in a that storage folder in a JSON file instead of in memory. So we will use the os.path.exist method to check whether that directory exists or not, that storage directories exist or not. If not exist, then what we will do is we will embed the document which we already have the code for that. So we will use the same code, and we will also use the same code to use the vector store index. And now what we will do is we will use another method to store this embeddings into the uh, storage folder which we have mentioned in persist directory variable. So for that we will use the index.storage.context.persist method, and we will pass the directory where we want to store that embeddings. So now we have already done the code for the persist the embeddings on a local disk. Now what we will do, if the directory exists, then we just need to fetch from that particular storage folder, get that embeddings and assign it to index object. So for that we need to use another package. So we need to use the storage context uh, package. Okay, we have imported storage context package. We will use this storage context. Okay, so sorry, storage context object, and okay, but there is a problem actually. Vector in store index is removed. Okay, so now it's good. So let's call the from details method from storage context. Inside that from details we will pass that persist directory path. Inside that we will pass the persist directory path. Okay, so it's done. Okay, yes. Now what we will do is we will initialize the index object, and we will use another package. For that we need to import it from the LlamaIndex.core library. So the library name is load index from storage. Inside that package we will pass the storage context, because it will take a storage context and return index object, and it will load the embeddings from the local storage and pass it to index object. So now our persist persistence code is done, we can test this application. Let's run that command again, python space demo.py, and let's uh, check how embeddings are stored in a storage directory. So currently there is no directory created, but it is now embedding the our document, and once the embedding is completed, it will store all the embeddings in the storage folder will get automatically created. So you can see that the storage folder is created, embedding is done, application is started. So all the files required by the llama index is created inside the storage folder. You can see that the vectors are stored. So let's question now. Let's question what is the document about in the document in details. You can see. Let's see what answer will be there. Yes, the answer is given, and it this time it given in detail. Let's ask the questions. What is the simple types in CCC? Explain in detail. Okay, the simple types are is so the questions it will automatically send the context to the LLM depending upon the question. It load from the our embeddings and send that to the LLMs. So you can see the all the questions answer of all the questions is giving quickly. Let's ask out of context question, what is the Sachin Tendulkar in CCC? Let's see what answer will be. There is no Sachin Tendulkar mentioned in document, so you can see that it said that it do not have enough information to provide the details. So this way you can create an application to query your local document using LlamaIndex and Gemini LLM with embedding. If you like this video, please like, share with your friends, or if you are new to my YouTube channel, then subscribe my YouTube channel. Thank you for watching this video.